For what positive values of t does this series converge? Okay, so we got t to the n over 2 to the n times 3n. If that n weren't there, this would basically be geometric. But that n is there. So what should we do? Well, something that occurs to me might be we could use the ratio test. Now, why would I think ratio test? Well, there's a lot of division and products going on here. Not a lot of, well, not any sums or differences. So the ratio test is great with multiplications and divisions. Okay. So let's work with the ratio test. Now, this isn't the only approach, but we can just sort of show off the ratio test here. Okay. So let's leave the actual value of t alone for a moment and see what we can see. Okay, our sequence is t to the n over 2 to the n, 3n. And the ratio test is based entirely on this row value. Okay, so let's go ahead and see if we can compute it. We'll keep the t in there, and hopefully we will get an expression involving t at the end. And then we can use our knowledge of how row behaves with the ratio test to help work out what t's work and what t's don't. Because, well, when it comes to positive values of t, there's an infinite number of them. We can't check them all. And so a result like the ratio test, with its inequality, its comparison with row, can help us cover a lot of them. Okay, so what can we do here? So t to the n plus 1 over 2 to the n plus 1, 3 times n plus 1. I'm just going to write that as 3n plus 3. All over t to the n, 2 to the n, 3n. Okay, so we can rewrite this a little bit. Actually, you know what? Now that I'm thinking ahead, I think I'm going to want to leave that 3 where it is so we can cancel out with the three from the 3n. And that's okay. It's okay to change your mind. So those 3's can cancel out right away. Most of the t to the n plus 1 can cancel out with this t to the n. Most of the 2 to the n plus 1 can cancel out with this 2 to the n. So what we've got here is t over 2 times n over n plus 1. Well, t is fixed, 2 is fixed as far as we're concerned here. We got n over n plus 1. Well, the limit of that is just 1. So overall, our row value is t over 2. Now, we know that we get convergence if row is less than 1. So that happens if t is less than 2. We know with the ratio test that we get divergence if our row value is greater than 1. So that corresponds to t being greater than 2. So the only question left is, does it converge with t equal to 2? Okay. So you see the power of the ratio test there? We covered a lot of situations. Okay. So now, t equals 2. I guess we just need to look at it on its own. Okay, so if t is equal to 2, the series that we're adding up looks like t to the, but that's going to be 2. So 2 to the n over 2 to the n, 3n. The 2 to the n's cancel out. And so our series is just 1 over 3n. And that's 1/3 times a very familiar series. Why, it's our old friend, the harmonic series. So this should diverge. Okay. So t values less than 2 will result in convergence. because anything bigger than or equal to 2 will give us divergence. Okay? So we had to use some ratio tests there, and then there was this sort of borderline case that corresponds to rho equal to 1, where the t and the 2 are actually the same, and, well, with rho equal 1, ratio tests can't tell us anything, so we had to resort to other means. And we just noticed, oh, okay, looks like the harmonic series.